So good evening, everybody, and welcome to the second installment of our Sliver lecture series for the fall semester. Today we have a very special guest that I'm honored to present, Mr. Hensel. Mr. Hensel is an architect, researcher, writer, and educator. He's a tenured professor at the Oslo School of Architecture and Design, where he directs a research center for architecture and tectonics. Previously, he taught for 16 years at the Architectural Association in London and held visiting professorships all over the world. He's the founding and current chairman of Ocean Design Research Association, an international interdisciplinary network of architects, designers, and researchers, and the SEA, Sustainable Environment Association, as well as a board member of BIONIS, the Biomimetics Network for Industrial Sustainability. Since 2007, he's an editorial board member of the Architectural Design magazine, published by Wiley. It is really difficult to call this publication a magazine, as its rigorous and progressive themes and thorough analyses really set it apart from many architectural publications that publish glossy images and general commentary. He has edited many issues of AD that has a research-based tone, which help determine an objective for design and fabrication using computational methods. His writings on design research, performance in architecture, sustainability, and other hot topics are always full of information, direction, and meaning, and is a breath of fresh air in the contemporary scene where such terms are used so freely, usually without much focus, intention, or rigor. A few words about the works of Ocean. Professor Hensel is the director of Ocean, a nonprofit organization conducting interdisciplinary research in design and is actively represented in Barcelona, Gothenburg, Istanbul, London, and Oslo. Current members of Ocean have diverse backgrounds in architecture, biology, civil and structural engineering, computational design, industrial design, musical composition, and urban design. Ocean's work has been published and extensively exhibited, including several architectural biennials in Venice and renowned venues such as the Frog Center in Orléans, where Ocean exhibited a solo show in 2008. Ocean operates transdisciplinary research through systematically organized and specific research topics. This experimental strain of work has had a great influence on the way we make sense out of the contemporary linkages between technology and architectural experimentation within the scales of form, fabrication, material research, and sustainability. It is a unique and tremendously successful model of interdisciplinary interaction and synergy between tangentially related design fields and sets a gold standard for many architectural research initiatives all around the world. Without further ado, it's my utmost pleasure to welcome Professor Hensel at the IoA.
Thank you very much for the invitation and the very kind introduction. So, having received the invitation by the Angewandte, for which I'm of course most grateful, I had some thinking to do. Do I just present some work as I usually do? Or do I try to dress it up in kind of wider outlook that I would like to share about architecture? And I obviously decided, judging from the title, that I went for the latter. And provocatively, I call it Confronting the Current Crises of Architecture. You see crisis here in plural. This is not a mistake, because I do think that at this very moment there are a number of things amiss to do with our discipline. I've just listed a few for you because really to go into the whole shebang, into the whole sort of network of difficulties that our profession currently faces, I would like to just pick out a few. It is true that journals like AD and others, Arc Plus for the German readers and so on, do take a critical stance on a number of things. But when you look across the board, you will see that there is quite a range of different kinds of topics. They typically go around some sort of urban themes, a little bit to do with sustainability. There's always some digital themes, and so on, fabrication and what have you. But when you start reading up, in almost all instances, these kinds of discourses are more specialist. They're more kind of isolated. They don't lend themselves to reflecting back on the larger picture of things. I know that I'm vastly generalizing here, but I'm always glad to see that here and there what I say is not the case. I also do think that formal experiments belong to the same issue by now, to the issue of fragmented specialist discourses. Until and unless we open this question to other kinds of things. I will pick up this theme once again. I also think that right now we're suffering more and more from a kind of redundant, inherited dialectic that divides form from function. You can see this very nicely when you open up a book like Formalism, edited by Jascha Grobmann and Aaron Neumann. A very nice book which originated from a fantastically interesting exhibition. And in this book, there are numerous contributions, and these contributions chiefly break into those that say form is still a true field of experimentation for architecture. Forget about function, that's an engineering topic, and function diminishes the freedom for formal exploration. And on the other side of that divide, you find the functionalists that go like, oh, but you know, all this formal stuff, artsy-fartsy, and no content and all the rest of it. So, how do you integrate two discourses that wish to be apart? In my view, this is becoming increasingly redundant because it doesn't help us to pursue other, perhaps more integrated forms of discourses. One can say something relatively similar about ecological and sustainability approaches, which typically look at a not too wide range of aspects related to sustainability. It may be environmental sustainability, then very quickly you move into energy calculations and how to fix this with technology and advanced materials, and so on. So how do we move there forward into an integrative approach? I think it is fair to say that we can perceive today a lack of communication between practice and education, even though protagonists from both sides would make statements to the contrary. And you will find a lot of practitioners teaching, but do they teach what they do in practice? And what is the relation between these two things? And if they, above and beyond that, also claim to do research, how does the research come to play in education? How does the research come to play in practice? And how does it unify these two fields in the communication? One thing that is very painful for me is to observe that architectural education has, not everywhere, but by and large become a kind of service industry which is managed not by architects but by managers who are interested in how many students are being processed and to keep liability cases, i.e. failing students, at an absolute minimum so that nicely the machine can keep rolling out numbers of students. How many architects do we need? How many architects do we have? How many architects are jobless? I tried to research these numbers. It's impossible to get any idea other than in a particular country or a particular region. But I do think these are pertinent questions because when somebody manages a school that produces 3,000 students in architecture every year to graduate, that person needs to ask the question, is that actually a responsible thing to do? Of course, much bemoaned, we have an increasing shortage of good clients. What does that mean? I heard somebody else refer to that as we have a lack of educated clients. That doesn't mean that clients don't have a school education, and in most cases even a very good one. But the point is, are the clients educated in the field of architecture to know that what they're asking from you and our other colleagues is actually something worth the while, or something rather anemic in a way? And by and large, much, one can then also ask the question, what is really the public interest in architecture today? Above and beyond Stuttgart 21. You know, when do people take an interest in what we're doing? And until and unless we get the public on our side, and perhaps a few good clients, how is truly integrative, complex, interesting, good architecture to arise? So one of the questions that comes up, and that's one that is paining me a lot, and I'm trying to work a lot on that, but not with great, amazing output up to this moment in time, is what should constitute core knowledge in architecture today? Do we actually test that? Or do we rely on syllabi and curricula of universities to tell us, by way of the different knowledge fields, what architecture is? Or do we rely on chambers of architecture and architectural contracts to tell us what architects do, and thereby define what core knowledge is? Or do we look at handbooks? Do we test really what core knowledge could and should be today in order to have some sort of idea whether we're moving in some sort of promising direction or not? And how should such knowledge be produced? One point that I wanted to make here, at risk of being shredded, is to make a claim that, in my view, idiosyncratic architecture, highly expressive architecture by virtue of relentless repetition, becomes the new generic. Take Rem Koolhaas's argument about the generic, and what he refers to as generic architecture. You can picture it because he supplies you with pictures for it. Now then, take one of these pictures and remove all the kind of rectangular buildings and place all sorts of biomorphic buildings in there, and then look again. Is it any less generic? Or does the idiosyncratic require a certain distance to other idiosyncratic expressions in order to remain special, in order to stick out, to stand out? If everything stands out, nothing stands out. And what do these buildings produce on their edges? Is it any better than the boxes that are produced? We had a short conversation earlier on about Istanbul. Istanbul is now in the construction phase on steroids. Go there, have a look around. You can get a very interesting idea about all sorts of different kinds of models of architecture being executed today. Try and see what the qualitative differences are. It's scary, actually. Then the question is, if we confront issues such as sustainability and so on, and our tendencies to solve such issues technologically, predominantly, why do we do that? Why don't we approach these problems from a spatial and material point of view, more predominantly than with technology? One should think technology is what does the last bit that architecture can't do. But today, architecture does a bit and technology does the rest. That is a kind of weird proportioning to me, because I ask them, what do we really do as architects? Do we stuff architectures with technology, or do we try to offset something in the design? How do we do it? And where do these things come from? Why do we have these very strict singular divisions between interior and exterior that need to be reorchestrated in their exchange with the environment through technology, because it's no longer done spatially? But not all is lost. If one looks around, there are always, time and again, very interesting projects that suggests that somehow the core matter of architecture, the spatial material organization, the envelope, the ground, the relation of the building to its immediate context, also meaning the local physical environment, can be thought of in different ways. And a lot of architects in their portfolios surely have a number of projects, reasonably less, but still they are there, that are worth re-examining for this kind of reason and for that kind of purpose. So I stepped out of practice around the year 2000. I had enough of it. This kind of Dr. Jekyll, Mr. Hyde, pretending at the IoA that we can do all this funky stuff while at the same time not being able to turn this into projects. So I thought maybe a little break from practice in order then to see how you gradually inchworm your way forward in order to retain some of the qualities and the things that you are interested in. So I would say most of my collaborative efforts with my colleagues are chiefly placed in the domain of research. And there are these three aforementioned contexts in which this takes place. Ocean, which is a kind of highly interdisciplinary research environment where we do partly very strange things. The Sustainable Environment Association, where we currently analyze 50 case studies of pre-industrial buildings to see how integrated spatial and material solutions could be drawn from there and updated. I will show some examples in a second. And of course the Research Center for Architecture and Tectonics at the Oslo School of Architecture, where we experiment through construction and, as it were, the simulation of practice in an educational environment. This is not a commercial break. I wanted to show you current publication efforts from our side, and that they actually form, in a way, a continuum. That you have actually 3 to 4 publication strands that are interrelated. In the core, in the center, you can see one row, which basically questions what are the means by which we may produce knowledge in architecture today. What is research by design? In my view, a pluralistic field. A lot of people say research by design is nonsense, it's undefined. I would vouch for the contrary. I would say there are a lot of very specific definitions around there, but they're not uniform. There are many researchers around that don't know very well what they're doing, and they can describe very well what they're doing by way of research by design. But it is not a uniform definition. The question of core knowledge again. And then at the top row, you see an effort that is gradually trying to build by a theoretical methodological framework to work towards the kind of spaces that a lot of the leading projects seem to suggest today. But how can we get behind there? Can we get a hook into this, and can we somehow define those things better? At the bottom you see a kind of struggle with what the current discourse between the global and the local, and between past, present and future architectures, what that might entail. So for instance, if you look at AD Turkey, AD Iran, the question is really to try and figure out, is there such a thing like Turkish architecture today? Or is there such a thing as Iranian architecture today, which is even more complex if you consider the vast diaspora of Iranian architects everywhere? And if there is such a thing, what are the characteristics, and could they be brought forward? And can Iranian architecture only be truly Iranian when these architectures are in Iran, or can they also be somewhere else? Interesting questions about sensibilities above and beyond the more general idiosyncratic architectures that we see today. And of course, the publication strand that relates to the building of a theoretical methodological framework is underpinned by a whole series of publications that try to show examples, concepts, working methods, and so on. In my view, none of these publications can stand alone, because if that was the case, they would just further fragment the discourse as they are today. So then you have a little bit of conversation about emergence, a little bit of conversation about material systems and so on. So what? Unless it falls into a bigger picture, just another book for the bookshelf. So, what I want to get at is architecture as a kind of modulator of the environment that interacts between different kinds of domains. And I like to think of architecture in terms of active agency, as architecture doing something, not just being there. I just noticed with the light on the screen, these things might be very difficult to read. So, but it's not a problem if the light needs to be on. I just wanted to say here that I personally right now work on 4 domains that I see processing active agencies and that interact and together make the human environment. One is the local biotic environment, local communities, ecosystems, biodiversity, and so on. The other one is the local physical environment, the lithosphere, the atmosphere, the hydrosphere, and so on, all local and contextual, that interact, of course, without humans directly in an unmediated way. But the moment you intervene and you place an architecture there, this architecture is beginning to affect that relation. And how does it do so? Can we break it into a number of interrelated parts that we might look at and try to understand in their own right? And I try to do this through a series of key concepts, such as material performance, the active architectural boundary, looking at the articulated envelope as an extended threshold between interior and exterior, or the larger environment and the control environment. Different degrees of auxiliarity of architecture, where it might be supplementary to something that already exists, or embedded, deeply embedded in the context, and what does it mean? Does architecture always mean the subtraction of ground, or can architecture multiply ground? And finally, what do we learn out of this for settlement pattern and processes? I will not go through all of this because that's way too much for a day, but I'll give you some examples of what these approaches stand for. Let me first start with material capacities on a smaller scale. It is very obvious to everybody who studies architecture that the properties of a material stand from its composition and structure. And the moment you put a material into a dynamic environment, it will behave. For instance, thermal length changes due to temperature changes and so on. If this behavior was harnessed and put to task for design, then we could talk about material performance. But if we take a simple material, or not so simple, like wood, what do we really need to know about this material? How far do we need to go? If you truly want to harness material capacity and material performance, you really need to make yourself quite a range of sources that you need to look at, and they quite often bring together contemporary scientific knowledge and also contemporary fabrication methods, because those methods alter quite drastically materials. If you think, for instance, about using a saw on wood, you destroy the fiber, so something quite radically happens. But there's one thing that we should not forget about, and that is traditional knowledge and craftsmanship. For instance, in the case of Norway, where I'm currently working, this is really still an alive tradition. And people there have an incredible knowledge about how you pick one piece of wood versus another for a particular task. Where this knowledge is no longer in existence, the only way forward is extensive experimentation. In other words, you need to work with the material in the field of its behavior that you're interested in. With materials like wood, you have also, of course, the luxury to look a little bit at wooden materials that are natural and how they behave. For instance, the seed pot that cracks open by virtue of moisture loss, which causes a twisting of the two halves of the seed pod that will then crack away from one another. This is caused by fiber directions in layers in opposite directions. So for instance, if you were to make a laminate, instead of saying you need to stabilize the laminate so that it doesn't curve, you do the exact opposite. And you wet the laminate and you dry it, it will actually acquire curvature. It will do what wood naturally does. It will twist and warp and do its thing. If you do enough research in this manner, you can do it in a very controlled way. So all of a sudden you don't need to mill, or you don't need to build massive molds or formworks for this kind of panel to have this form. Quite interestingly, this can be brought forward to working with very thin materials and asking whether they could develop structural capacity. In other words, working with wet wood that is put into a particular shape, and when it dries, shrinks, and thereby puts pre-tension into a system. So what you see here at your bottom right is somebody wetting the structure here to not dry too fast, because otherwise it will pre-tension, and then you have difficulties to get the other parts in. So, on the one hand, you want to do enough physical materials in order to be able to work forward in the digital domain and to produce the construction information. On the other hand, all of a sudden you need to pay attention to other things. If the wood indeed needs to be kept relatively wet during the construction process, you need to see, for instance, when you assemble in the exterior, where the sun is acting the most on that structure, because these are the areas you need to wet the most. So all of a sudden, environmental analysis becomes quite important, also for the assembly process. On the whole, what I have briefly introduced looks a little bit like this. The 3 rows show 3 different steps. The top starts with extensive material experiments and trying to build the corresponding computational logic. Below is a proliferation of that work in a computational domain and doing the important analysis that relates to what you want to get out of your design. And at the bottom, the construction process. I will not pester you with this for too long, because a lot of people are now working in this kind of way. I just wanted to show you one example by what I mean with utilizing material behavior. And in fact, it is possible to build a structure out of 0.75 millimeter thin pine veneer due to the fact in which the material behaves in drying and pre-tensions the entire structure. Now, this exchange with the environment in the case of wood is called hygroscopic behavior. Wood seeks for moisture equilibrium with the environment. In other words, if it's more humid, if there's a greater ambient humidity, the wood will take this humidity until there's equilibrium, and when it gets more dry outside, it will give that moisture off again. You can see here a photo that my wife has taken last year. It's a kind of wooden frame in our house that was rained on all night long and then hit the sun the next morning. It's actually quite a visible vapor there. That made me think that a blur building can actually be accomplished not necessarily by technological means, but by knowing exactly how you distribute mass and material in the environment. So if you truly want a blur building, while of course you have the issue, you may not always have the blur when you want it. It will be there when the moisture is there, but that is a way of getting there. In a way, you can put the material to task. And maybe here I will just refer one more time to an earlier statement. Why do we first look for a technical solution if, as architects, we should be more inclined to look for a spatial and material solution before we enhance those things that cannot happen in this way with technology? Now, one thing is also quite interesting in the research that we're doing in Oslo. We have actually realized that we can do any amount of research in the School of Architecture, and yet that research will never make itself out into practice and into the built environment. Why? First of all, because we can't obtain any great variety of wood, because the 2 predominant species in Scandinavia today are pine and spruce. So if you want broadleaf wood, you already have some difficulties to acquire it. In other words, if that's already a problem, we need to look at the entire supply and demand chain. We need to talk to the forestry guys and say to them what we want. But of course we have a time lag, which starts with birch trees about 40 years or so, and it goes to several hundred years when it goes to oak trees and so on. But this time lag should not discourage us from talking to these guys. Because somewhere in between there is the wood processing industry, and they are even more slow and sluggish than the forestry guys, because the forestry guys have now to answer questions of sustainable forestry, which is only possible through biodiversity. So they have a pressure, we have a pressure. In the middle sits a kind of dormant industry that doesn't really have too much innovation pressure, at least not in Scandinavia, because they have enough to sell. Everybody is building a nice little pine tree house. So once you realize this, that you actually have a confluence of, that your interests go into the same direction, that is at the bottom and at the top of the supply and demand chain, then you can move things forward. But still this is not going to work if you don't take the craftsmen that are supposed to work in the kind of way in which you wish to implement something with you. So you also need to find some sort of way of integrating, identifying the important educational institutions that you should take on board, and then doing a kind of coordinated education of all the people involved in making such an architecture. Enough about materials, but I want to raise a different topic. And that topic is, we are supposed to make architecture more sustainable, whatever that means. In the context of Scandinavia, that means in the main bulk, housing projects from the 1950s, 1960s, and also 1970s, which are spatially not rich enough. There's not enough space for social interaction and so on. Plus, they're, from an environmental point, not very good. So what do? You cannot take all this huge amount of architecture down and replace it with new buildings. It takes a while. The resources are not there, both financial and otherwise. So auxiliary architecture, in the sense that I want to talk about it for a few minutes now, is a kind of architecture that is an add-on, something you add to the existing bulk of buildings where you cannot change these buildings. Otto made an interesting remark in this regard. He said all architectures are auxiliary, and he uses the example of the bridge being auxiliary to the road system. This may seem an overly simplified example, but I will show you later on an example of a bridge that is far more complex. We try now to, as often as possible, build full-scale prototypes. And in order to learn a lot about what we do, we try to use Norway or the world as a climate laboratory. So you see here the projects that we have constructed over the last couple of years in terms of these auxiliary architectures. And they're in quite different climatic contexts. Here's a brief overview over some of the projects. Again, in order to move forward, it's highly work intensive. You need to do a lot of physical experiments. This, by the way, was the workshop in Izmir. It was a lot of fun. And the question is, how much enclosure should be provided for an already existing building as an additional envelope? Of course, you don't need to put yet another full climate envelope around a building that is not performing very well from an environmental point of view. All you need to do is reduce the environmental impact on the building, i.e. the wind force that is a cooling effect on the thermal mass of the building. So all you need to do is to make sure you identify the environmental criteria that you want to affect, and then see how close or open such an additional architecture should be. Plus, of course, there's a consideration what kind of purpose it serves. But analysis is always critical. So this project you have probably seen before, so I'll just very briefly show it as one of the early examples. It was a membrane canopy we did at the Architectural Association in 2007. And here the question was, how do we reduce the wind force on the insufficient substructure? And that was by breaking the whole membrane roof into small portions, which also allow a way of steam through and towards the Imagination building, the first building built by one of the Archigram members, Ron Heron. And here, for the first time, we try to link the computational procedures with analytical procedures to be sure that in such a kind of patchwork roof, the rainwater runs off, and that in a way you have a sufficient rain cover, that you produce the protection in relation to solar impact, and that even though you reduce the horizontal load on the structure, that you don't accelerate the airflow between the structures so that the poor people that are standing there are freezing to bits. Now, putting full-scale structures into context has one advantage. Things happen that you don't expect, like snow in London. Usually everything stops, but one thing does not stop, your observation capacity to actually go there and see what happens with something that you have not designed the system for. And one realization that we had here is that we would have to increase the inclination of this roof for the snow when it has piled up to a certain height to fall off. Otherwise, it will close the surface, and then it receives the full horizontal load from the wind, and it will probably collapse. So when these systems are developed, they need to be tamed by another system. What I want to say by that is here you have two examples. The orange membranes each have their own set of cables connecting to the perspex box around. And this space between the perspex box and the membranes is intersected by these cables, so it's not inhabitable. The example on the right-hand side has a cable net moving with the membrane system to reduce the amount of cables that are intersecting the space and therefore make it inhabitable. Even scaled models, physical models taken out into context, can tell you something when observed at a particular season over time. At the Flight Center, we built such a system to see in the full scale what the implications are for constructing such a thing. To learn something about the constructional logic. And again, at ISNIR, where all of a sudden we had 100 students for 2 weeks, we could go entirely systematic and develop 20 systems that are all quite similar looking if you squint your eyes, but if you look closely are very different. Again, we built a prototype here. This prototype was mainly intended to deal with the light condition inside of a fairly dull corridor, to shade during the morning hours and to amplify the light during the evening hours. Other examples are freestanding structures that could be added where the existing building bulk is not capable of receiving any tension or compression loads. Actually, in London, this was rather precarious because the tension anchors were sitting in the brick surface, not something I would ever want to do again. It's a bit risky. And more and more examples, in this case, at the Cooper Union building in New York City, where views, sites, and communication between users were the important factors, so more programmatic issues rather than environmental ones. And here just the project that I will talk a little bit later about, that we constructed this year in the full scale in a very harsh environment. So right now we have yesterday completed a studio at the Oslo School of Architecture where we looked at these systems again, and due to the weather conditions did our construction experiments in our construction hall. But what we're doing too is we're trying to build the studio so that the physical and digital experiments can happen concurrently, and that we are able to simulate those things that we are not able to construct through augmented reality functions, which also help to visualize the force flow in the system or the flow of air through the system. And also virtual reality functions that allow you to literally move through a design and see it without it necessarily being constructed. It's just part of an extended evaluation process. And aesthetical criteria for evaluation are equally valid as functional criteria. This was just a brief excursion into this topic of auxiliary architecture. The next topic is a research project that is now going into its third phase, design and construction for difficult environments. What I will show to you are a few very modest projects, but in their own right, they had to tackle a number of difficult circumstances. The first two phases took place in Chile, the first in Patagonia, the second one in the open city in Ritoc. And now we're planning for the third phase for a project in northern Norway that we will do in the spring. A brief overview of the project. The first project we did in a difficult environment was in Chile and Patagonia, and the brief was actually very simple and not very demanding. It was merely a shelter and a viewing platform for a fjord-like bay where you could do some whale watching. However, the structure was to be implemented in such a manner that you would disturb the ground at the very least. This is a very pristine nature site, where all the material, at least in terms of the wood, would come from the site. And here we have the problem that no live trees can be cut, so basically we had to consider only cutting trees where there was a forest fire and floating them down the river. So basically the length of the trunk was determined by the bends in the river to float these trees down. Earthquakes, of course, and high wind loads along the Pacific coast, particularly in the winter. So in the design phase, we had to work with Buro Happold very hard on trying to figure out how the kind of elaboration of a fairly simple geometry consisting nearly out of planks of a given length would be stable or not under the impact of earthquake. And we had to do a fairly extensive airflow analysis to consider how the horizontal loads will act on the structure. An additional difficulty was that the construction had to take place in 7 days, and that all the material and tools that were required had to be taken on a very small sailing boat to that site. So down to the last nail, in a way, even though this being a very small project, the considerations had to be fairly specific. The second project we built was a small bridge, and this bridge has 4 pylons and then rows. The difficulty here on that same site, again, not to disturb the ground too much, but we also had no idea of the ground profile. In other words, nobody did a test dig there to know where is bedrock and where is an old riverbed, maybe just filled with big stones, and where do we have sand or loose soil. So we had to come up with a system that allows a kind of free disposition of the pylons within certain limits on site. So after our test digs, we were able to determine the precise locations of the pylons and then to build the bridge. So here, one of the difficulties was really building in the unknown. Basically designing for a condition that is critical but not known at the point where the design needs to be determined. Then very briefly, 3 projects that we completed this year in the open city. The open city, you probably know in Ritoc, a very fantastic educational experiment by the Catholic University in Valparaiso. They actually commissioned somewhere in the early 1970s Alberto Cruz, a very important Chilean architect, to rewrite the curriculum for education of architects at the university, with the main question being, what is the architecture of South America? Not an easy task to address this. He teamed up with an Argentine poet, and they wrote a very huge manifesto, and as part of the rewriting of the curriculum of the school had to purchase a very huge piece of land along the Pacific coast, where buildings are constructed, designed and constructed in collaboration between the professors and the students. But these are not by any means simple buildings. These are actually accommodations for professors where they live all year long, workshop facilities, meeting facilities, and so on and so on. So buildings with different specifications. We were invited to add 4 structures. One was experimental, I will very briefly touch upon it, and the other 3 had a more distinct brief. The first one was supposed to be a temporary accommodation for a visiting scholar. We added this little bridge deck because we wanted to use, of course, the opportunity to experiment with something. Here we have earthquakes, we have high wind loads, and we have foundation in sand. So if you have this long, light, underspanned bridge, is it actually able to withstand the winter storms in Chile? I was told the projects are pretty much intact still, but I'm very much looking forward to see some more detailed photos of the membrane structure, which I think cannot be entirely intact. Of course, a lot of engineering analysis prior to go into that. Construction on site. That studio was dealing with issues of scarcity on top of everything else. So what kind of materials can you actually purchase for the minor budget that we had for this kind of construction, and are those materials in such a way provided that you can justify environmentally to work with these. So a finished project. Unfortunately, I cannot show you any photos of what happened since. I'm still waiting to receive them myself. Either it was a full catastrophe and the guys are embarrassed to send us the photos, or I don't know. Maybe they're just a bit slow. The second project shares some features with the first one that I showed in Patagonia. It is again a ruled surface project, but this time one that is open and see-through from 2 sides and closed from 2 others. It's a bird observation point right next to the bird reserve and the ossuary of the river that cuts across the side. But this project I wanted to talk a little bit more about. This is a facility that has some enclosures for cooking and food preparation, and then this kind of sheltered eating place. So it's a project that is not necessarily auxiliary to another architecture, but it is auxiliary to the dune landscape in which it was supposed to be placed. I'm not going too much into the development of this project, but what is really quite interesting is when you look at the force distribution, we have 21 point foundations on that side, all to be set into the sand. But almost every one of them experiences a different set of force combinations. Some are pure tension, some are pure compression, some alternate between compression and tension depending on the horizontal loads, and some of them have tension and compression at the same time. So it was not really easy to work through a kind of small project of that sort, making sure that the high forces that act on it, and particularly membranes, which seem counterintuitive in this context, will work. Again, a lot of analysis was necessary in order to ensure that the project would at least not fly away with the first little breeze. The construction project and the finished project. One issue we realized only on site, simply because we should have had more extended conversations about materials. There's a real problem with steel in this environment, and it's not just the obvious, it's not just the sea salt that eats away on the steel, but there's a copper smelting plant nearby, which increases massively the acidity of the moisture particles in the air. So you can say even stainless steel is gone after 7 years. Galvanized steel, maybe 3 years if you're lucky. For lack of budget, we had to do this project all with galvanized steel, so it doesn't have a very long time span. We were also told that in this particular part of the site, poorer people that live in the area scavenge for firewood, so I would imagine that a lot of this would have already warmed some cold hearts. Yeah, just to show briefly, this is the space we produced for the cooking facilities and so on. And lastly, on that side, this is a project done by my wife. She's doing a little research into complex brick structures. This is a non-reinforced single-layer brick structure, very obviously inspired by Gaudi's work. The form-finding process is relatively similar, chain models, but interacting catenaries, interacting chain lines, which give you very odd geometries, actually catenary arches or catenary shells that come to a point. So this is the system hierarchy from the brick to the arch, to the shell, to the interacting shells, and then this kind of dome structure. In order to handle this, we had to work with Boma and Passer, one of the best engineering companies in Barcelona. They did pretty much everything from the Torre Akbar to all sorts of other projects in Barcelona, the Bullring Center, and so on. First, it started with assessing singular arches and their geometry through the modification to see the stress pattern. It went on to combinations of arches, and finally the construction. But of course, the brick that you can obtain in Chile does by no means have the same standards as the engineered bricks here, on the basis of which this was calculated. But nevertheless, the important thing was to find someone who knows something about calibrating the relationship between the brick and the mortar in such a way that their elasticity is in tune. And so I have been told that since we left, there have been about 15 or so earthquakes above 6 on the Richter scale, and the structure still stands. So now we can move forward with this and to try and see whether we are able to produce enclosure. If you want to close the edges with a brittle material, say for instance with glass, everything becomes a question of the edge stiffness of these shells under, for instance, earthquake impact or under other kinds of loading scenarios. Okay. You're still waiting for some big architecture, but I'm kind of like just moving around it. I'm not going to show you any kind of big architecture design class today. But out of a conversation we had recently with the chief editor of Art Classic Journal, Sabine Kraft, she suggested that it would be quite interesting to look at architectural history again, but not from a style or typology perspective, but from a performance perspective. And so we have embarked on doing 50 case studies of projects. They're all in the initial stage pre-industrial, and they're globally distributed to address different kinds of issues that people had to work with and try and solve. This comes back to the question of the production of knowledge in architecture. There are two levels of questions here when I show you these projects. The first level of question is, how was the knowledge produced by way of which this particular building was constructed? But the other question is also, in which different kinds of ways is knowledge produced, or has it been produced throughout architecture history? The obvious is, of course, the vernacular. Generation by generation, small improvement or alteration, and word by mouth from the master to the apprentice. But there are other instances which are apparently without precedence. Then where does this knowledge come from? I just show you 5-6 examples of this that are all interesting in their own right. The first example is a small kiosk. It's a kind of multi-purpose summer building in the Topkapi Palace in Istanbul. This particular one has been used for many different kinds of purposes, but it is quite interesting because it has a huge amount of arcaded, what we think of as secondary space around a fairly small interior. And the walls meander, they create different kinds of protected pockets. Interestingly, in this miniature, you can see the kiosk on the right-hand side, and you will see these textile drapings. They are not only curtains to give more privacy, they are also environmental modulators. They shade, but they let the air flow through because it's a textile. So basically what you see here is an early example of what you might call auxiliary architecture or supplementary architecture. It does something spatially, programmatically, and functionally for that kind of space. So, of course, we first model these kinds of projects. We look into them, also we make scaled physical models of them. We study the plans and sections. Here you can see quite clearly this meandering wall, and if you imagine now a particular sun path and a particular prevailing wind direction, you can quite easily imagine that each one of these pockets is quite different on the interior and on that secondary arcaded space on the exterior. In some places you get more sun, in some places less. In some places you get more wind, in some places less. And so you don't tune some sort of air conditioning unit, you just move a few meters until you're comfortable. But the question is how, if and how they were able to fine-tune this so that there's always some range of comfort zone around it. And in some of the instances of the projects where the people that have designed or maintained these buildings are no longer there to ask, we need to do a lot of analysis to figure it out. Similar to this kiosk in the center of this little forest here, the Fin Garden kiosk built at the same time in Iran, but a totally different spatial organization. The four innermost spaces are on the corners of the building, and the building is transected by two axes of external space. So all of a sudden you have much more exterior surface. How does that work from a thermal and climatization point of view? Again, a lot of analysis in terms of shading and also the contribution of the vegetation to that, whereby we can only assume today whether the vegetation was like this to start with and whether it was intended to be like this. Just a few images to show you this building, and here a section that shows you how on two axes the building is intersected by exterior space. Now I want to speak for 2 minutes about two different types of visualization. What we're doing here, these 50 case studies, they are not only intended for architects. The intention is to exhibit these buildings and to draw the general public back into an interest of architecture and to show that historical architectures were not despicable slums, but that they were also actually quite nicely thought through. In order to communicate complex information about airflow, you can have a rendering like this, which barely shows you the ground plan and the airflow, and these kinds of images are very, very difficult to understand for anybody who's not trained. Or this kind of image where you can recognize the building, and then I can explain to anybody who's not an architect what the colors mean, for instance, velocity of airflow, or when we look at colors on surfaces, that this is air pressure, this is like force acting on the building, then all of a sudden we're a step closer to communicating more complex information to a general public. Similarly with this water system, also in Iran. So if you have water that it is to some extent open to ventilation by air, how do you keep that from being contaminated? It's a very important question. It's also a question about the temperature of the water body, so that any contaminants that may actually end up on the top surface of the water are not able to spread. Or a very intriguing typology, ice houses, which are typically built in the desert. And what is done there is ice is produced overnight, and it is stored in a dome of this kind of sort. Here you see a little section in the plan of this. But how is ice produced? There's a water pool here, about a meter deep, surrounded on 3 sides by the wall. And then of course the storage facility behind. Now the first thing that obviously needs to be done, because you're in the desert, you need to keep the pool from heating up during the daytime. So this is a thermal analysis that shows you the average thermal impact over a day on that kind of surface. You see that due to its orientation, due to its three-sided protection, the water pool is not affected. Look at the sun path. We see a similar kind of position. And if you look at the analysis of the prevailing wind directions, you see again that the wall shelters the pool. So the pool is not warmed up by the sun and the wind, but how is the ice produced? That's an interesting question. And the answer to that is fairly simple. It's radiative cooling to the night sky. It's heat loss to the night sky. And it is so effective that several centimeters of ice are produced in this pool every night. So an interesting question is, when it comes to maintenance of these buildings, and believe me, there's nobody around that you could possibly ask about this. These people are not there anymore, and these buildings are not used anymore. You need to make a quick analysis about how much ice is produced under certain circumstances over 24 hours. So here you see two interesting curves. The more shallow curve indicates harvesting only once a week, and you see this curve is becoming more flat in terms of the depth of the ice produced. And that is merely due to a very simple condition. The thicker the ice gets, the more it shields from radiative cooling, so it gets slower and slower. But if you were to harvest at an interval of 1 day, you see that after 7 days you have probably more than twice as much ice produced. Then something completely different, the pigeon tower. These kinds of typologies, they are built to house up to 10,000 semi-wild pigeons. And they are kept in order to take the droppings as fertilizers for the fields and to use them in the tanneries for working with leather. How do you design for pigeons? A particularly awkward client. You cannot talk too much with them. Like, are you comfortable, guys? So how do you do this? One part of the answer is simple. Very obviously, this typology comes out of the vernacular tradition. It probably started with very small boxes for pigeons, and it grew in size and in sophistication. Part of that sophistication is that you have a slippery surface here that makes it impossible for reptiles to come up that wall into this building. As you know, birds have generational memory. If ever a snake or a kind of reptile makes it in there, the next few generations you see no pigeon in there. Really bad, not good. This is how these pigeon towers look on the interior. Now, how do you make something comfortable for pigeons? So first of all, it's a question of thermal impact. The available building material is adobe. Very thick walls, they need to be thick because of earthquake impact in Iran. But on the other hand, they need to be thick to reduce the thermal impact. Here you can see on the hottest day of the year, 4 different times of the day, you can see that at some point the outside of the building heats up to 34 degrees centigrade. But you can see that the interior remains at a constant around 20 degrees centigrade. This is surprising when you see that these towers also act in a similar way as the famous wind catchers in Iran. There's a lot of effective ventilation into this building to have air exchange because, of course, you can imagine with all these pigeon droppings, which are only harvested once a year, the air can get fairly lousy in there. I've been told by some people that have actually that these towers still stink today, even though there are no droppings. But the point is really this. How do you get the velocity of the airstream along the cooling or warming surface so well modulated that you keep the interior constant? They do it. They didn't have to do any computational analysis to do it. We have to do computational analysis, and we have to ask all sorts of guys what the pertinent questions are to ask here in order to learn something from that. And as a final quick example, I promised you to show you a little bit more of a sophisticated bridge that does several things at the same time. This is the Hardin Bridge, again in Isfahan. And here we come to the question of knowledge production. I will get to that because this bridge, in its combination of things that it does, has no precedent. that became enriched by some additional thinking and by gradually increasing the size of the project. This one is very different. First of all, on the upper deck, the bridge connects the two sides of the city. Nothing much about that. On the lower deck, it is the weir with sluice gates, and it regulates the water level of the river upstream so that the gardens can be supplied with irrigated and so on. But there's something else that is rather astonishing about the bridge. People congregate here at the lower part because it's very comfortable, climatically speaking. And the reason for that is that the air that streams through these voided spaces here is circulated over the water body. Evaporative cooling makes this air very comfortable. In other words, this place is a social condenser that the Shah provides for his people. Here in the center of the bridge, this dark block is actually a small kiosk, like a pavilion, that symbolizes the presence of the Shah and him sort of providing for his people. If you really look at it from an analytical point of view, there's something rather interesting happening here. It's not only with regards to the fact that you have a lot of turbulent flow, in other words, that the air keeps circulating over the cold water body and therefore cools the place. But it's also slowed down so that when you sit there, you don't feel an uncomfortable cold airstream. Again, it's a kind of double coordination that is really astonishing if you think that there is really no precedence. They built this thing and it worked. So, how about knowledge production? How do these cases come into existence? One obvious logical consideration is that the component parts are known and elaborated. Yes, there are other bridges that were weirs with sluice gates. Yes, there are other bridges which are bridges. Yes, they have a long tradition of knowing how to deal with airflow in vertical structures, not necessarily in horizontal structures. So yes, it could be simply kind of juxtaposition of existing forms of knowledge, but then how do they get it right so much? And I think there it's always quite interesting to see what actually happened historically at that very moment in time. This was right at the moment of time when Shah Abbas I established Isfahan as the new capital of the Persian Empire. It was mainly to do with pressure of the Ottoman Empire, and so in order to do that, he pulled people from some of the regions that he didn't want to leave to the Ottomans, Georgia, Armenia, and so on, towards Isfahan. But also craftsmen and scientists from all other parts of the empire. And all of a sudden, you had a confluence of different knowledge types and knowledge fields that could interact and speculate in a very informed kind of manner and then come up with a project. To my mind, this is the best indicator that our preference today for interdisciplinary work is right. It's really going in the right direction. We have to bring knowledge fields together for something interesting, new, more sophisticated to happen. But I owe you still a few statements about two things. The first thing I should make some statements about is the question of the local physical environment, in particular the climate. One of the problems that we have in Norway is that all the building regulations and standards are based on one connection point of climatic data in Norway. That is near the old airport in Fornebu in the south of Norway. Then this is multiplied by a factor to make up for the fact that very much in the north buildings are much more exposed. But this uniform regulation is used everywhere else, which means that in a lot of locations you put vast amounts of materials without need. So how fine should a set of measurements be, and can you really account for local climatic differentiation? Where we live, outside of Oslo, between our valley and the neighboring valley, it can be up to 10 centigrade temperature difference at the same time in one day, at the distance of 1 kilometer. The reason for that is our neighboring valley is a cold trap, and in our valley the weather moves through. So in that cold trap, the cold air from the north comes in and is basically captured and just sticks around there. And so when I drive by car in the morning, it might be -5 in our place, but a kilometer further it's -15. Can architecture really address this? Is it possible? Is it feasible to do that? And if so, how? And what is sort of like the climatic data that one tends to work with? Usually one tends to work with general climate differentiation and then Köppen-Geiger system and so on, and then some kind of regional temperature differentiation. In Norway, that is not just north to south, it's also east to west from the sea to the higher altitude. That produces a vast amount of local temperature differences. But how even to start? We don't know yet conceptually. I cannot tell you what conceptually the consequences are. But what we're trying to do is this. We're trying to develop very cheap weather stations based on Arduino technology with sensors. Each one of those less than 50 euros a piece. So that with a research grant, we are able to put several dozens, if not several hundreds, over a suitable area that can work as a test field. And these report either if there is a wireless system via Bluetooth or otherwise with a SIM card directly to your handheld devices. So basically what this device is receiving here is every 2 minutes a reading of humidity, temperature, etc., etc. So the first thing we really need to know when we measure somewhere, what are really the effective differences? And then we can begin perhaps to address them from a conceptual point of view to see what that might mean in terms of architectural design. So really, if we look at the way in which we're working computationally and otherwise today, that we have these kind of iterative processes between form generation and analysis, what does it mean to feed real-time data, maybe weather, maybe seismic or otherwise? What does it mean to feed that into the process? We don't know yet. The other question, I showed some images a little bit earlier on, are to do with augmented reality and virtual reality immersive visualization. In other words, to facilitate students and non-experts with the possibility of understanding what it really is they're looking at. Because when you look at the typical analytical drawings of engineers, they take a level of expertise to understand what it really is. So communication of such complex issues is important. And then lastly, this is the last theme that I want to address for today, is the question of the pigeons and the pigeon towers. Architecture and ecologies towards a anthropocentric architecture. What does that mean? I'll go straight here. So, if this is your architecture, must be double tuned with red. But we said red is not a color, so that doesn't matter. If that is somehow architecture, as a division between interior and exterior, then very clearly what we design is predicated on an anthropocentric provision, the interior for the human. For instance, to give a simple example, a lot to be seen in England these days, old rural buildings where the cold roof is transformed into an insulated roof, bats by pest control, who knows. So it's actually showing that more and more of the structures are really centrally focused on the needs of humans and no longer in any way possible to inhabit or to appropriate by any other species. So what if that intervention, this material and spatial intervention, would become more spatial so that it produces intermediate zones and pockets where those bats could still be, in spite of the cold roof having turned into fully insulated and climate-controlled space. Is such a thing thinkable? And why is it necessary? Well, urban ecologists have made quite a bit of progress with putting policies and actions into place, but if architecture cannot sustain it because of its insistence on a different kind of focus, then we have a problem here, because on the one hand, on the large scale, something is supposed to happen, and on the other hand, the large scale is an agglomeration of a lot of small scale things, and these small scale things don't take any action in that direction. Then what? Probably this, because that's the only way how to handle it. There's no space for these guys. When he wants to move in, we show the door. When they want to move in, they show the door. Obviously, because when they move in, they cause a lot of destruction to your roof, to your insulation. We have currently, my mother has an animal living in the roof, between roof tiles and the insulation, and the whole thing is turning into a mess. Shit everywhere, but interestingly, they make different compartments for the little ones, for the parents. So they have a bedroom and the kitchen and so on. Integrating animals into their physical, spatial interventions that make the environment is not a new thing for humans. This is Cappadocia. Some of these wonderful carved houses, but look at the effort that is taken to make small provisions for pigeons. A huge effort. They have to like chisel away quite a bit, even though the stone may be soft. It is an effort. Or Transylvania. Here, this is not vampires. This is also young pigeons in this upper part of this gate to a property. And more poignantly, in these kinds of rural buildings in the west and southwest of England, where literally the gable wall is shared with another species. Of course, you could say, well, these are all domesticated pigeons and there's somebody having a hobby. But look at this, every house in this neighborhood has this. Why don't we have it? Because we lost tolerance for this. But for the Iranians, that was a commodity to be put onto the field. So that is really an interesting thing. In order to move this topic forward, it's very much about what you tolerate and what you don't tolerate, what may be seen as a commodity or at least as a value, and what is not seen as a value, what is seen as a nuisance, as a destruction, and so on. And we tend to relate like this more often than not. But it is, in fact, quite interesting for architecture students to engage for once at least in the study of an ecosystem to understand what kind of relations are taking place there. Because systemically speaking, these relations are very different from the ones that we tend to work with in architecture. Mainly because we construct things as a product that is then given over and that will have its own life. But no such thing here. How do you even need to visualize such kinds of relations? To which extent do you need to look into the plant morphologies or the morphologies of certain species, into their physiology, into food chains, etc., etc.? On the other hand, though, back to urban ecology, there are now more and more efforts, at least in Europe and also in the United States, to map out local biodiversity. There are research groups, governmentally funded mostly, springing up everywhere, where a succinct effort is made to quickly register what is there before it is so modified that it's meaningless to map biodiversity. And so, as a model for architects, because we plan things and we coordinate things, it is quite interesting to look at a field that's called urban ecosystem management, where on the one hand the farmer plants a biodiversity, what kind of crop cycle in order not to exhaust the ground and so on. But with making these decisions, something else happens, an associated biodiversity. If you plant crop A, you will have bacteria B and C in the ground as a consequence. The associated biodiversity is a consequence of the plant biodiversity. And all of that is taking place in a larger natural environment wherever still to some level intact. i.e., for instance, bat populations that interact with different pests that might be there, or insects that might be there because of a certain plant biodiversity. So the issue of what you plan, some part of consequence and some part of uncontrolled issue, there are other disciplines that have to tackle it. And they provide perhaps suitable models that needs to be thought through and converted for architecture. So back to this for one last time. What does it mean, well, this is hardly readable, to have a data bank attached to your entire design apparatus, whatever that might contain, conceptually and methodologically, and to feed the information, for instance, from the biodiversity and mapping efforts and so on, into this as a kind of input into the design. That could be really rather interesting. And right now, we're collaborating with Cornell University for the second year in a row to drive this topic forward. How can architecture begin to design for biodiversity? How can it do so, even if it is on a very modest level for each little building built somewhere, but in some total, the overall agglomeration in urban areas is substantial. Finally, I cannot answer the question that I started with. What should constitute core knowledge in architecture today? How is such core knowledge produced? But we're pursuing a number of avenues that I was talking about here that are all placed around somehow what is common practice in architecture, and that would inform that. I don't want to say that we can do better everyday architecture. We, as in my research environment with the people that I collaborate, surely we cannot. But we can probably help enrich it with a number of questions that will shed light on what kind of expertise we might need to gain. In some instances, you don't have to become an expert in ecology, but you need to know some first principles. In some instances, you don't need to become an expert in climatology, but you need to know some first principles, and so on. So how do you actually make that judgment? As a student, as an educator, as a researcher, where you should invest that time and do this kind of thing. All I showed to you today is part of that integrated effort that I tried to show to you with the publication streams, where one theme is elaborated from one publication to the next and maybe split and become several themes at once. So is that a way out of the several crises that architecture is facing at the moment? I don't know, but it would make architecture a little more interesting. Thank you.
Questions from the audience?
I think that one of the tendencies is that architecture is acquiring ways of looking at the world and ways of knowledge production that it shares with sciences. That's one tendency. And I think it's a significant tendency, and it can be seen across the field. But that doesn't mean that architecture pretends to be a science or will become one. I think one of the more interesting arguments that I've heard in that regard was by an architect that studied with West C. Churchman, a systems theorist at Berkeley. And this architect's name is Harold Nelson, and Harold Nelson claims that the creative disciplines are not merely an intersection between humanities and sciences. They don't merely straddle these both domains in some sort of efficient or inefficient way. He basically says that the creative disciplines are a kind of third column, if you like, and that this third column is characterized by a number of abilities of the people that are doing something in this field. And he identifies adaptive capacity as one of these. So as an architect, as architects, we are quite often able to adapt to different configurations of problems and to deal with them. And for a while it was quite interesting for researchers in the field of complexity to bring architects in, because architects have this kind of adaptive capacity. I believe more that architecture will, as part of the creative disciplines, will remain within this third column, but it will also acquire more aspects from the sciences, as the kind of responsibilities that we inherit all the time are increasing, and we have more and more questions to answer.
Yeah, I have one question. I mean, I very much like your animals in the house, and I think all the people have used Adobe knew what it is if you have classes in your walls and the plants do things that you and also kitchen houses were something that was a common feature in Europe in innovation. You see them in many organizations because people highly assess that manual. My question now is, I mean, we also know architecture, we have a practice of exclusion, and it, to a certain extent, it segregates. I mean, in bourgeois society, it segregates what is private from what is public. It segregates what is cold from the warmth, what is outside climate to comfort zone, and so on. And I very much like your idea that there is a kind of continuum in many ways, so that there is a kind of ecosystem, and it's also the way how architecture is done, and everything is related to everything. But are there any kind of exclusion strategies, or is architecture in the way how you understand it something that only goes with the flow, or does it have an imperative of its own in order to establish a certain type of organization?
Yes, I think it would be foolish to say that architecture doesn't have that. And clearly I wouldn't want to share the same space with pigeons, mainly because I don't want to bring all sorts of respiratory diseases upon myself and so on. So yes, I think that architecture can continue some part of its necessary agenda of division, but they can be next to one another. It is defined by a finer grading of the divisions. I think that's sort of what I would say. I don't think that, I don't have this kind of idea that architecture would become a kind of replica of Garden Eden where everything happily coexists now. But I think that studies, for instance, that are currently taking place in Seattle by Professor Mansloff and so on, who looks into urban avian populations, are very interesting because it's very much about interaction. How come that certain species thrive while others not? It starts, for instance, by the people that live in a neighborhood taking a liking of one type of bird versus another, and they start feeding them and then they thrive. This is no longer, in a way, a kind of natural situation, but it is very much a kind of evolving situation. And then the question is, then there's also architecture. Can architecture also do something with this? For instance, if there's one species that's already nicely provided for because the people that live in the neighborhoods like it, what do you do with the other? You let it diminish or you make something for it? But still, I'm kind of talking around the topic. I think that division is not something that I would wipe off the plate. No, it's on the contrary. It's necessary, but I'm talking about more fine division. Finely graded division.
I can have one more question. Because in our school, in the architecture school in this university, people are always talking about that we are missing the real scale experiments. And seemingly this is, also when you're referring to the topic, this is something that is the center of your agenda. And you would say scale 1 to 1 gives you experiences that you could have no other way. Also with you, because you're also using augmented reality, you're using simulations, you're using models, but seemingly there is something, let's say, irreducible in real material or physical presence.
I would say yes on several accounts. First of all, I would say that on account of the experience of the students that go through such a project. And normally, unless something really bad happens, this seems to be an enjoyable thing that students like to do. As a kind of experience of realizing a line drawn on paper is actually very hard to materialize. So on that account, it produces a valuable experience. But on the other hand, you see, we have a loophole in the Norwegian planning regulations, and that loophole is that buildings up to 15 square meters that are not permanently inhabited can be built without planning permission. So if we truly want to know whether a particular way of constructing is suitable for different kinds of environments and what this might mean in terms of maintenance, and these experiments don't have a precursor where we can go and ask somebody, then it's a valid way of gaining the information. A simple example is that the timber houses that are closer to the fjord, right on the water, versus where we live 500 meters away. These houses, they need to be cleaned every 2 years with the chemical on the outside. They need to be painted every 3 years, whereas about 500 meters back you do that maybe every 4 to 5 years. Or you do something entirely different about the protection of the wood, not so close to the water you can't. Because whatever you do from a kind of spatial organization or protecting with roof overhang and so on, doesn't really keep, or it doesn't keep in bay the general ambient humidity in the air. So to relearn some of these things, or to find some strategies for ways of designing and constructing that don't have a precursor and don't have the knowledge, it is quite a useful thing to do. I don't think anybody needs to do that. In our case, it's purely on a voluntary basis. The students can decide to take such a thing as a studio, but they don't have to. And we just have to put this research center into place in order to use the opportunity that we now have a kind of government in Norway that is supporting these activities. So on the one hand, the government supports activities like these little very well designed projects along the scenic highways, which is called the National Tourist Project. And it is more about adding architectural quality to a wonderful landscape, minute things. And our mission is slightly different. We, of course, also want to have as much design quality as we can possibly have, but we also have an additional research agenda. So my colleague and I, we were pulling ropes in opposite directions when we were doing the Topic project, and we were doing this little unit for somebody to sleep over with this deck. First it was only this unit, and I said, look, I need to report some research back. It's good that we have the design, but there's nothing to report. Can we not do something? And the students had this idea that they wanted to make a cut in the landscape and extend this bridge so that you get some sort of poetic relation between landscape and the horizon. Actually, a very interesting thought, and then they also came up with the fact to make the unit as a kind of contemplation of Le Corbusier's house for an artisan. So all of a sudden they had architectural ideas. And then I said, okay, right, now we're talking, because now I have a long underspanned structure, and it's very difficult to solve this from a structural point of view. So we can also have research value out of this thing. So it's a little bit of both. It's a little bit of for the students to see design ideas that they have materialized at least once. And on the other hand, I have to pull lots to get also some research output that I can report at the end of the year to justify my expenditures. But I must say the Norwegian construction industry is incredibly reluctant to do something because while I think maybe architecture could do with a little bit less crisis of the sort that we have now, they could have a lot of crisis at least because they're complacent. They don't have enough competition. If you look at the wood industry in Austria and in Switzerland and in the south of Germany, people are really moving ahead. They're innovative. They're really doing something. In Norway, they are not moving ahead.
They're too rich. They're too rich.
They are too rich and they don't have competition. They have done something about eliminating competition, so they are really complacent. And for instance, Helen and Hart, probably an office that you also now know. It's a better known Norwegian office. They did the pavilion at the Shanghai Expo, the Norwegian pavilion and so on. They do a lot with wood, and they try to convince one of the Norwegian wood industries to work with them. They refused. Helen and Hart did all projects subsequently with companies in Austria and Switzerland and the south of Germany. And after a while, 2 years later, the Norwegian company went bankrupt. Because they didn't see any reason to upgrade, to innovate, there was no pressure until it was too late. That is a disadvantage in our case. Now, I think here much more could be done in this kind of way because there's much more competition, there's much more innovation. I think this entire region is probably the one with the highest patent rates in the world. So, yeah, I think a context like this would be really beneficial for such experiment.
Okay, I'm allowed to have one last what I thought was really interesting was your micro map of diamonds. Because it just happens so that I share diamonds collapse. And there is this chapter on Greenland and what the Inuit do and what the Vikings would not learn. And he was also constantly talking about being close to the fjord, being away to the fjord, or the sun exposure, and so on and so forth. Is that your major hope that we can save most of the energy if we have a very precise micro reading of what is really going on in terms of climate? And would that produce a new, very differentiated and specialized vernacular? Or are you going to come up with a toolbox of solutions that can be combined according to what is necessary in a specific situation?
At this moment, I don't know, because I think we have to first... My first hope is that we create a sensibility for these differences. But conceptually, what will be the consequence of doing this, I don't know it yet. I have, of course, some ideas in my mind, but I don't know it yet. I think we really need to undertake that study and then see what we really do with it. It is, of course, hope that a little bit of both will be done, that there will be some kind of integration in the way in which we think and design, maybe a kind of sensibility and maybe some tools. Tools that are affordable. Everything we do with virtual reality, augmented reality, we do it as an absolute minimum price. We don't have a computer case. We basically just bought like a simple Connect unit and we got some free downloadable software from the, we work basically almost at zero cost. We try to make these devices and tools as cheap as possible because if they are not cheap, if they are not affordable, people will not be working with them. There was such a big hype about these computer caves and all these simulations some years ago, and when you now go around to the universities that have those, there's maybe one person who would know how to work with it, but the thing is usually sitting in some dark basement room and nobody's using it. Too demanding in terms of running it, too expensive in terms of buying it, and so on. So we are basically working at the absolute low-cost solution. Robots? Yeah. I had to... we were having a beer with my colleague who were doing this kind of little weather stations, and I had to calm him down the other day. He wanted to Yes, maybe, but step after step. I'm usually a cautious character. I like to make sure that we know what we're doing step by step by step. But a lot of my colleagues, they would like to be like 30 steps ahead. So it's somewhere in between that we're working. Some are racing ahead, some are pulling back, and then somewhere in between